Let's look at experiments and causation in organizational psychology. We want to know under what conditions can we say that one thing causes another, that A causes B when we measure A and B. Let's start off by looking at an example. Suppose in a certain city we have a lot of data, and we have data about ice cream consumption, how much ice cream is purchased in the city each month, and what the monthly crime rate is. And it turns out that ice cream consumption is correlated with the monthly crime rate, R equals 0.63. We've got like 5 years of data. So we have like a data point for each month. We'd have like 60 months. And we can see that the months that ice cream consumption is high, the crime rate tends to be high too. It's not a perfect correlation. It's R equals 0.63. Does this mean that eating ice cream causes criminal behavior? I don't think so. That wouldn't make any sense. How would uh, eating ice cream cause criminal behavior? You might be able to think of some word that, well, or some reason for this. Maybe people that eat a lot of ice cream get brain freeze and start acting crazy or something. That's not very credible. You could go out and get data to see if brain freeze perhaps is the cause of this, but it just doesn't make sense. There's probably something else causing uh, both the crime rate and buying the consumption of ice cream, and that's the case. It's the temperature. When it's hot, crime rate goes up. People are outside more, they're out late at night, causing problems. They get more irritated. There's more crime in the summer than there is in the winter, and in the same way, we ice cream consumption is greater in the summer and the winter. So we see this cyclic pattern that corresponds both to ice cream consumption and to crime. But how do we demonstrate causation? If a simple correlation doesn't demonstrate causation, what does? How can we say that one variable influences another? Well, I would like to propose that there are three necessary conditions to demonstrate causation. Now, causation might actually occur and we can't prove it, but here's three things that will provide very strong evidence for causation. First of all, the cause and the effect, so the independent variable is the cause and the effect is a dependent variable, need to vary together. That means they need to be correlated. The R has to exist, and it has to be beyond chance. It can't just be this weak correlation that's not significant. It has to be significant, something that we can trust would happen in other populations that are or other samples from the same population. Secondly, the cause needs to precede the effect. Um, if A causes B, A has to happen before B. So if ice cream did cause criminal behavior, we would have to see in individuals that they buy and eat ice cream in general before they go out and commit a crime, or that eating ice cream after eating ice cream they commit more crime than people who don't eat ice cream. But there's that time factor there, because if it's the other way around, we would say A couldn't cause B if B occurs before A. Now, if A and B occur simultaneously, we don't know which one's causing which, or maybe they cause each other. Um, this happens a lot in organizations. People get, let's suppose we have organizational commitment and quality of relationship with the boss. If people get committed to an organization, they're going to invest more in their relationship with the boss. So A could cause B. But if they invest more in the relationship with their boss and they have a better relationship, that can cause their organizational commitment to come up. So that's what's known as a complex system when the causation occurs in both directions. which is usually what happens. But we're typically satisfied if we can demonstrate that causation can occur in one direction. Now, perhaps it can occur in the other direction too, but we need to show that a change in one leads to a change in the other, that the cause needs to precede the effect. And then the third thing that we need to demonstrate is that there are no other plausible explanations on why they vary together. And that we can't think of something else that would explain why A and B vary, why there's some other third factor that would cause both A and B to vary, like we did with the ice cream and the crime rate. And the main way that we demonstrate that there's no other plausible explanation for the event is we conduct an experiment where we randomly assign participants to two groups. And that means we take a bunch of participants and we randomly assign them so that there's no difference to the groups beyond what we would expect by chance. So in our ice cream consumption and criminal behavior, we would have to get maybe 200 people, 100 that will eat ice cream for a month and 100 that will not eat ice cream for a month, and see if there is a change in criminal behavior. And the only difference between the two groups is the consumption of ice cream or not. And so if the ice cream consuming group does commit more criminal behavior, then we'd say, aha, we found evidence that consuming ice cream causes criminal behavior. But more likely, the criminal behavior of the two groups is not going to be different. If anything, maybe those who eat ice cream are happier because ice cream is so good, and they'd be less likely to cause crime. But the key feature of an experiment is that people are randomly assigned to two groups, and in each group receives a different treatment of the independent variable. Here it would be no ice cream versus ice cream. You could do 1 scoop of ice cream per day or 2 scoops of ice cream per day. That's called the manipulation of the independent variable, or the treatment that each group receives. And that's the only difference between the two groups, is this change in treatment in the independent variable in a well-designed experiment. So if there is any difference between groups concerning the dependent variable beyond what we would expect by chance, it's probably due to the different treatments of the independent variable, the ice cream consumption. Now I say it's probably due to it because, there might be some confounding variables that we didn't see, like maybe when they were eating ice cream, they got exposed to some violent message on the ice cream container, and it was really reading the ice cream container. There's always a possibility that we have these things that will mess up the experiment, and we have to be really careful in our experimental design. So let's review the 4 causal interpretations of a correlation, because it's important to remember that correlation does not imply causation. So if 2 variables A and B are correlated, there's 4 causal interpretations. A causes B, so that would mean that A comes before B. B causes A, if B comes before A, or a third factor causes both A and B. And it's not A causing B or B causing A, and that's where we could use an experiment to find out if we don't include a third factor, we only manipulate A and B and no third factors come into play. Or it's possible that the correlation is spurious, it's due to chance, we wouldn't find it in another sample, it's not significant. P is not less than 0.05.